In October 2019, if you knew where to look, you could see it with your naked eye. Betelgeuse, the right shoulder of Orion, one of the brightest stars in the sky, was fading. Not a little. You could see it. By February 2020, it had lost a third of its light. Astronomers pointed every instrument on Earth at it. The VLT, Hubble, every ground-based observatory with a clear line of sight, all them watching. And to this day, they don't all agree on what they saw. Before I show you the data, I need to tell you what we are actually looking at. Because Betelgeuse is not a star in the way the word star usually lands. It's something else entirely. If you place Betelgeuse where our Sun is right now, its surface would extend past Mercury, past Venus, past Earth, past Mars. It would swallow Jupiter. This is not a star like our Sun. This is something closer to a catastrophe in slow motion. It sits 700 light-years away in the constellation of Orion. It is burning through its fuel at a rate our Sun couldn't sustain for a week. And it is old. 8 million years. Ancient for a star this massive. It is, in the language of stellar physics, a red supergiant, a star in the final chapter of its life. Red supergiants dim and brighten. That's normal. The surface of Betelgeuse is not still. It churns. Giant convection cells, bubbles of plasma rising from the interior, move across the surface and cool as they reach the top. You have seen water boiling in a pot. The bubble that rise, spread, cool at the surface, sink back down. That process on our Sun produces convection cells roughly the size of Earth. On Betelgeuse, a single convection cell is roughly the size of Jupiter. So yes, Betelgeuse varies. It always has. Astronomers have been measuring its brightness since the 1830s, a rhythm of roughly 400 days. Brightening, dimming, brightening, dimming, consistent for nearly 2 centuries. What happened in 2019 was not that. The AAVSO, the American Association of Variable Star Observers, is one of the most extraordinary citizen science projects in existence. For over a century, amateur astronomers around the world have been pointing their telescopes at variable stars and recording what they see. Night after night, year after year, hundreds of thousands of observations contributed freely, compiled into a public database that anyone can query, including me, from my laptop in Rome. You don't need to understand astronomy to read this. This is the brightness over time. This is the light curve. Every point is a measurement. Brightness over time, decades of it. You can see the rhythm, the 400-day cycle, rising, falling, consistent. And then, here, the line drops, not a normal dip, something outside the range of everything before it. I measure it. The magnitude dropped from 0.54 to 1.56 at its minimum, a drop of 1.02 magnitudes. The star lost 61% of its visible brightness, not a third, not two-thirds, and then it came back. By April 2023, it had returned to its brightest record level. The crisis, whatever it was, appeared to be over. But the 400-day rhythm that had been beating for nearly 200 years, gone, disrupted. The heartbeat of the star knocked out phase by whatever happened. I ran a frequency analysis on the data. Before the dimming, one dominant period, 369 days. After, that peak has vanished entirely. That is what I wanted to understand. What happened? There were two ideas, and both made sense. The first, a massive convective cell, one of those Jupiter-sized bubbles, rose to the surface, cooled, and temporarily darkened a huge portion of the visible disk. The star dimmed from the inside, a natural, if extreme, version of what Betelgeuse does all the time. The second, dust. Betelgeuse ejected a cloud of material into its own atmosphere. That material cooled and condensed into solid dust particles. The dust sat between the star and us, a veil blocking the light. The star hadn't actually changed, we just couldn't see it properly. Both ideas were plausible, but had data supporting them. For 2 years, the community couldn't fully separate them. Then, in 2022, the Hubble Space Telescope settled it. What Hubble found was this. As early as January 2019, 10 months before the dimming became visible, a shock wave had moved through Betelgeuse's outer atmosphere. The star had already begun doing something violent. By the time anyone noticed the dimming, the event had been underway for nearly a year. What followed was a surface mass ejection, not a coronal mass ejection like our Sun produces regularly. Those are energetic but modest. This was something different. A chunk of Betelgeuse's actual photosphere, its visible surface, was blasted off into space. The mass ejected was 400 billion times greater than a typical solar coronal mass ejection. That material cooled as it moved away from the star, and as it cooled, heavier elements, silicon among others, condensed into solid dust. A cloud of stellar debris hanging between Betelgeuse and the Earth, blocking roughly a quarter of the star's visible surface from our line of sight. The dust caused the dimming. The ejection created the dust. And what caused the ejection, almost certainly a convective pulse from deep inside the star, producing shocks that blasted the surface material loose. 3 layers, 1 event. The answer was nested inside itself. And then, one more thing. After the ejection, Betelgeuse was different. The photosphere left behind was cooler, the chromosphere less dense, and the 400-day pulsation, the rhythm that had been measured consistently since the 1830s, simply stopped. For more than 2 years after the great dimming, it was gone. As one of the lead researchers described it, the interior was bouncing like a plate of gelatin. The star was struggling to rebuild itself. And then, in 2025, we found something else entirely. Betelgeuse is not alone. Astronomers confirmed the probable detection of a companion star, a smaller star orbiting Betelgeuse at close range, already inside its outer atmosphere. It has been nicknamed Betelbody. It is expected to be swallowed by Betelgeuse within 10,000 years. Whether this companion had any role in what happened in 2019, nobody knows yet. Every answer opened a new question. Something happened to a star 700 light years away. The violence of it was sufficient to knock out a pulse that had been beating since before any of us were born, before any living person's grandparents were born, before the first photograph was ever taken. And we noticed. From here, with the light curves and Hubble ultraviolet data and a public database built by people who just kept looking, night after night, because the sky was there and the question was open. That's what this channel is. That's what I'm doing here. Not because I'll solve it, but because the data is public and the tools are free and the question is real and someone should be looking. It is going to explode. We don't know when. When it does, it will be visible in daylight. It will cast shadows at night. It will be the brightest thing in the sky after the sun and the moon. We'll be ready.